Yeah, pressure is a big issue. Welcome to the Technical Forum of Hydrogen and Fuel Cells Europe. We have a lot of interesting presentations, and the next presentation will be about the importance and functionality of a pressure regulator. And we have the managing director of Pressuretech here. And it is, where is he? There he is. Steve Yorke-Robinson, please give him an applause. Oh, I can't talk anymore. An applause. I'm sorry.
Thank you. Good afternoon. My name is Steve Yorke-Robinson, Managing Director and owner of Pressuretech. It's great to be back at Hannovermesse after 4 years' absence and networking and meeting everybody. Pressuretech have 22 years' experience of manufacturing pressure regulators, previously within the oil and gas market, and over the last 6 years, last 3 years while everybody's been in lockdown, we've actually been ramping up and developing a range of pressure regulators for an extensive range of applications. In the last 12 months, we've recently achieved EC79 approval on the Auto 438 for commercial vehicles and TPED approval on an isolation valve, which I'll go into in more detail. So to explain a bit about what pressure regulators are, how they function, the different types of characteristics and the features that we've built into our design. Pressure regulator is basically a simple mechanical equation. Force is being pressure times area. So by compressing the spring on the regulator creates a force, which first of all has to overcome the inlet pressure acting against the main valve, which then opens the main valve and allows the gas from the inlet to pass through to the outlet of the regulator. That then creates a second force, so as the pressure on the outlets of the regulator builds up, that acts against the area of the sensor. Once those two forces underneath the sensor equal the load from the spring, that's when you achieve your required set point. Within this equation, you've got a lot of constant values. So the load spring, once that's set, that's constant. The area of the seat is always a constant, and the area of the sensor is always a constant. So if anything changes in your supply pressure, your inlet pressure, the only factor that can change to compensate that is your outlet pressure. So this is what we call an unbalanced main valve. Your inlet pressure is acting in one direction, pushing the valve into the seat. Typically, that can be 100 to 1. So for every 100 bar drop in your supply pressure, you can see a 1 bar rise, or up to 20 bar. And it's the ratio between the sensing element and the size of the seat that determine that ratio. So what we have at Pressuretech and what we've incorporated into all our designs is what we call a balanced main valve. So the principle still applies. You have your inlet pressure acting against the area of the seat, but it also works against the area of O-ring in the opposite direction, which then nullifies the loading effect. So you compress the spring, again it opens up the main valve, but in this case, inlet pressure times the area of the seat minus the inlet pressure times the area of the O-ring makes it a zero factor, or very close to zero factor. So that means the spring is therefore predominantly working against the outlet pressure. What that then means is that any drop in supply pressure means the outlet pressure stays fairly stable. So to see this in operation, this is an example of a compact mini regulator, unbalanced main valve design. So it'll be connected up to the system. In this case, we're only simulating it up to 200 bar. So 200 bar on the inlet will set then 1 bar pressure on the outlet. As the supply pressure depletes, as the gas is being consumed, what you'll see here is the outlet pressure suddenly increases. So without touching the regulator, your outlet pressure will rise. On a fuel cell application, obviously that could be an issue. So now with a balanced main valve, we'll repeat the test. Again, 200 bar supply pressure, set 1 bar on the outlet pressure. And then as the supply pressure depletes, what you'll see here on the outlet pressure is a fairly steady So it's increasing, but it's only 0.2 of a bar over the 200 bar drop. So it's a very stable outlet pressure control. Why that's important? On a lightweight regulator that we've developed for the drone market, you want that regulator as compact and as light as possible. You can obviously use a two-stage regulator, so we have developed a two-stage regulator where weight, size isn't a criteria. But for the drone applications, we've developed the LW351, single stage, balanced main valve, to maintain a steady outlet pressure. So you can see here, we've worked very closely with Intelligent Energy on developing this product. But the actual regulator can equally be used on other small vehicles such as bicycles or portable backup power units. So when it comes to actually changing over the gas cylinder, when the drone is out in the field, it's not really commercially viable to have a regulator on each gas cylinder that is supplied. So this is obviously the fuel source. What we've created here is a compact valve again, a bit like your Calagas or your barbecue gas bottles. When you connect the actual regulator to the cylinder, it releases the pressure and supplies the drone with the next source of fuel. Rather than having a bulky handle that can obviously get damaged in transit and adds weight to the actual gas cylinder, this compact unit sits on the cylinder itself. It's also been TPED certified, so it can be used in transportation of gas cylinders. You've got the 5/8 or the M18 threads, depending on your gas bottle supplier. So you can see here, this adapter will connect the regulator to the actual gas bottle. So by securing it on, it's a low torque device. You only need a spanner to connect the units. That pushes down on the valve pin and releases the gas to the inlet of the regulator. So it's a very quick and easy method of transferring over the gas bottles. So obviously, this will be a full gas cylinder on the drone. It goes off, it flies around for its 1.5 or 2 hour flight time, does its survey, comes back to base. And then the gas bottle is changed over quite easily with a wrench to disconnect the gas bottle and put in a new supply. So the regulator always sits with the drone or the vehicle. It's the gas bottle, which is a new fuel source. So this is the bottle connector that would fit onto the unit. And then the cylinder would obviously go back to the gas supplier. They'd connect up. Same mechanism, pushes down on the pin and allows the gas bottle to be refueled, ready for the next use. And likewise, whilst we focused on drones, there are obviously a number of areas where it's advantageous to have a gas cylinder that can be changed over out in the field quite quickly. I mentioned at the start, we've recently achieved EC79, so an opportunity to, I guess, plug our products. It's the same concept, so it's got a balanced main valve design, very stable outlet pressure, can take up to 350 bar, or tested to the 438 requirements within EC79. As you can see here, we've done 90,000 cycles, which is equivalent to 10 years use on automotive applications. So again, examples of where the products can be used: commercial vans, buses, flying cars, believe it or not, and white transit vans that travel down the motorways that they feel they can fly at sometimes. But commercial vehicles tends to be our market for the Auto 438. And finally, we're here to sort of expand our product range, as I mentioned, so we're interested to get feedback from yourselves. Our stand is just behind you there at A74. Two areas that are of interest to us are the refueling regulators and the Auto 875, so going up to the higher pressures at 700 bar supply pressure. We're interested to know what your requirements are, whether a single-stage balanced design or a two-stage regulator is better suited. So thank you for your attention. Any questions? Did I squeeze that in 10 minutes okay?
Good presentation.
Is that okay?
Any questions?
I guess I must have done.
Oh, just wait a moment. There's some pressure before lunchtime. Okay, so I would say thanks a lot for this great presentation.
You're very welcome.
Steve Yorke-Robinson.
Thank you. Thank you, everyone.